Adacel is the world leader at adapting speech recognition technology to ATC simulation and to other aviation applications, both in the cockpit and in aircraft simulation training. Speech recognition systems are not created equally. Effective application to the complex ATC world and the idiosyncrasies of the aviation language demand a more robust system than the mere incorporation of a lexicon and an off-the-shelf recognizer. Adacel has invested considerable resources and years of experience to create a state-of-the-art system. It is precisely this effort that caused Adacel to be selected to develop the cockpit voice recognition system for the F-35 Joint Strike Fighter program, and that continues to prompt major aviation companies such as Airbus, Boeing, CAE, Lufthansa, and Gulfstream to explore potential applications with us. Adacel's speech recognition and voice synthesis system permit an exercise to be run without the interaction of an instructor or a pseudo-pilot to generate vehicle behavior and to make the necessary voice transmissions. This allows individual or group training to occur without the need to staff supporting positions. It offers the potential to vastly reduce personnel scheduling issues and costs, while providing an effective tool to foster trainee proficiency in the ATC-specific language. Adacel's speech recognition system can be employed as the sole input mechanism or can be used in combination with pseudo-pilots if desired. An instructor or a supporting pseudo-pilot position can override a voice command with a manual input. Alternatively, complete control of an aircraft or vehicle can be assumed for a period of time and can be subsequently transferred back to speech recognition control. There are three key elements to a speech recognition system for ATC simulation. First, the voice input must be received and the spoken instruction recognized. This command must then be translated into a correct system behavioral response and an action generated if necessary. Finally, an appropriate synthetic pilot response must be created and spoken by the system.
59, hold short of runway 7 left, remain this frequency.
Roger. Hold short runway 7 left, remaining this frequency. US Air 1159.
US Air 1159, taxi across runway 7 left, contact ground on the other side.
US Air 1159, taxi across runway 7 left, contact ground when off.
For speech recognition to be effective, the simulator requires a thorough behavior system to assume the role of the aircraft pilot or vehicle driver. This artificial intelligence results in superior performance by producing consistent, automatic behavior even when pseudo-pilot positions are employed. Realistic behavior is fundamental to consistently achieving ATC training objectives. Our behavioral models permit the automation of intricate operations such as the ability to acquire and follow traffic on the ground or in the air, to give way to traffic, to cross behind specific traffic, and even to line up and wait behind a landing aircraft when instructed to do so. Not only can aircraft be directed to land on a runway other than the one they were programmed to use, but on final, they can be diverted to land on a parallel runway using only voice commands. The system must be equally capable of discerning and reacting appropriately to commands that are not valid to the target aircraft's situation. Adacel's system has the intelligence to do this without compromising the student's ability to manipulate traffic and to make and learn from mistakes.
Alitalia 6759 Tower.
Adacel's system is a speaker-independent continuous speech recognition application. It does not require pauses between words or phrases and does not require the user to train the system for individual voice patterns.
Iberia 320, enter right downwind, runway 35 left.
The recognizer is tolerant of accents, as well as quick, slow, and hesitant speech patterns. Speech processing is rapid, so as not to introduce artificial delays in scenario activity. The system permits a series of commands to be spoken together in a single transmission. It also allows commands to be issued to two different aircraft or vehicles in one transmission using the command word break between them. In its latest evolution, the system provides a form of situational awareness to simulate radio discipline. If the voice synthesis system attempts to generate a pilot message on an in-use frequency, the transmission will be cancelled. When the frequency becomes clear, it will be regenerated with updated information such as position reports if necessary. Command structure and the natural tendency for people to introduce wording variations and extraneous words and sounds into supported phraseologies is a complex issue. The Adacel grammar and speech processing is structured to support many wording combinations. At present, the system recognizes over 500 individual commands and many thousands of variations to those commands that can be used in a controller utterance. To give you an idea of the volume, a printed copy of the supported grammar structure would take around 1,000 pages. Adacel has developed a technology that has proven what the simulation user has known all along. Speech recognition, when done correctly, provides immediate training and financial benefits to the owner and operator of an ATC simulation system.